Hi, today we're going to learn about trigonometric functions of any angles. So this might be, I know on the previous lessons when we went over trigonometric functions. So this might be a little bit of review. So in this section, I will find the trigonometric function of any angle, and I will also find reference angle. So yeah, so here's all the rules we have to go over for this section. This is just like, I think this is just like our previous, but the thing is, remember how I said sine is also what was it? Sine is opposite. Hold on, let me form it. So remember SOHCAHTOA. So remember sine was also sine of x is opposite over hypotenuse. Okay, so now what we're going to do is use y over x. And the reason why we're going to do this is because what we're going to do is we're going to deal with Cartesian planes. And what we're going to do is we're going to draw triangles. And then you could think of it, this side length here is like an x, and then this side length here is your y. And then this length here is also called your radius. It's also a hypotenuse. So that's why we're using, instead of using opposite over hypotenuse, you still can use opposite over hypotenuse, but it's just much more efficient if you use y over radius for this, only for this section. Okay, so cosine is also x over radius. Tangent is y over x. Cotangent is x over y. Secant is r over x, and then cosecant is r over y. And then to find the radius, right, this length here, is the square root of x squared plus y squared. Okay, so yeah, okay, let's do the first example. So in example one, you're given a point, -3, 4, being a point on the terminal side of theta. Find the sine, cosine, and tangent of theta. So what I would do is always, when you do these problems, always draw the triangle, draw it on the Cartesian plane. So let's plot that point, -3, 4. And then we're going to somehow make a triangle, right? So -3 is, here's my x-axis, here's my y. So -3, so this is like an x value, and this is like a y value. So this is 1, 2, 3. Here's -3, and then up 4. 1, 2, 3, 4. There's 4. So somehow it's this point, right? And then you could think of it as like a, what is it called? In physics, it's called a vector. So that this makes a line right here. So somehow you make a triangle, right? So this somehow makes a triangle. Okay. So this length from here to here. Wait, first off, what quadrant are we in now? What quadrant are we in? We're in quadrant 2, right? So that means that in quadrant 2, the cosines are negative, right? And then the y value, or the sine, is positive. Just remember that, because when your final answer will have some negatives. So remember, cosine is also the x value. So this length here to here is what? -3, right? And then sine is also the y value. So this length from here to here is 4. Now, how do we find this this hypotenuse, or it's also called the radius? What we're going to do is use the Pythagorean theorem, or the formula. We could also use the r equals square root of x squared plus y squared, right? So what's my x value? It's -3. So it's going to be -3 squared plus, what's my y value? 4. So it's going to be 4 squared. So that's going to be square root. -3 squared is 9 plus 16. 9 plus 16 is 25. Okay, so the radius is 5, or also known as the hypotenuse. So this side length from here to here is 5. Okay, so now what we can do is we want to find two things, or three things: sine theta, cosine theta, and tangent theta. So let's find sine theta first. So sine, if you recall, based on your notes, it could be opposite over, what is it, sine? I forget. Yeah, opposite over hypotenuse, or you could also think of it as y over radius. I think I'm going to use y over radius. This is much easier than doing the opposite over hypotenuse, right? So what's my y value? It's positive 4. So replace y with 4. And then the radius is 5. And if you want, you could also do this SOHCAHTOA thing, the opposite over hypotenuse. So here's theta, opposite side would be 4, hypotenuse would be 5. So either way works. But I'm just gonna do it the other way. Now let's find cosine theta. Cosine theta is also x over radius. So my x value is what? -3. And then my y value, my radius value is 5. Okay, so that's why cosine is -3/5. And then the last one they want to find is tan theta. So what's tan theta? It's also y over x. So what's my y value? This is my y value, right? So this is 4. And then my x value is -3. Okay, so that's why it's 4 over -3. Okay, so also I forgot to show you this. This thing, this is called our theta. And then I think this, I don't think, I believe that this is going to be our reference angle. Okay, so that's that one. That was example 1. So now let's do example 2. So given theta, so in example 2 says given tan theta equals -5 or 4, and cosine theta is greater than 0 or positive, right? Find sine theta and secant theta. So what we're going to do is draw the triangle, right? Right. Yeah, draw the triangle. And then use what we have, use what we are given. So what do we know? We got to figure out what quadrant are we going to be in, right? So they're saying that cosine theta is greater than 0. So that means it's positive. So which quadrant is cosine positive? So quadrant 1. And what about quadrant 2? No, that's negative. Quadrant 3? No, that's negative as well. Quadrant 4. So these are the only quadrants that's where cosine is positive. Now, they are saying that tan theta is -5 or 4. And remember, if you recall, tan is also y over x, right? So we have a negative tan. So we can't use quadrant 1, right? Because in quadrant 1, tan is positive, always positive, right? Because the x and y values are positive. So our only option is going to be in quadrant 4. So we're going to draw our triangle. So remember, draw a triangle. So remember, tan is y. So it's -5 or 4. It's also y over x, right? Tan is y over x. So draw a triangle. Remember, this length here is your what? Y value. And this length here is your x value, right? So what is our y value? It's negative. We're in quadrant 4, so the y value is what? Is it positive or negative? Forget. 4 comma -3 x comma. Yeah, I was just trying to pick a point on quadrant 4. So the x value is positive and the y value is negative. So this would be -5, right? So that was given. And then our x value is +4. So we got to find two things, sine. So now we have this triangle, we got to find sine theta and secant theta. So what do we have to find next in order to finish this problem? We got to find the radius or the hypotenuse, right? So you could use the Pythagorean theorem or the other formula, square radius equals x squared plus y squared. Same, you're going to get the same answer. I'm just going to use the Pythagorean theorem. So it's going to be 4 squared plus negative 5 squared equals my c squared, or the radius. So that's 25. I mean, 4 squared is not 25. 4 squared is 16. And then negative 5 squared is positive 25 equals c squared. And then 16 plus 25 is 41 equals c squared. And then take the square root of both sides. You get c equals square root of 41. Now 41 cannot be its prime as can be, so you can just leave it as square root of 41. So this radius or this hypotenuse is square root of 41. Okay, so now we can find sine theta and secant theta. So sine theta, what is sine theta? It's y over radius. So what's my y value? It's negative 5 over my radius, which is radical 41, right? Thing is, you can't have a square root in the bottom, so you want to rationalize the denominator, so you're going to multiply top and bottom by the denominator, or square root of 41, right? So that's going to be negative 5 square root of 41. And then 40 square root of 41 times square root of 41 is just 41. And this is it. Sine of theta is negative 5 square root of 41 over 41. This cannot be reduced in any way, so this is your final answer. Now let's find secant theta. If you go back to your notes, secant theta is also radius over x. So my radius is radical 41. And then my x value is what? Positive 4. Okay. That's your final answer. And if you're curious about the decimal sign, this negative 5 radical 41 over 41 is about negative 0.7809. And then radical 41 over 4 is about 1.6008. Okay, so that was example 2. So all you have to remember is use what you have, use what you know. That's what they give us. So and then you have to draw the triangle. So we know that tan is cosine is positive in quadrant 1 and 4, and then we're only using quadrant 4 because tan is negative. Okay, that was example 2. Let's do example 3. Okay, so example 3 says evaluate the sine function at the 4 quadrant angles: 0, pi halves, pi, and 3 pi halves. Okay, so what I'm going to do is just draw the where all these I'm just going to label the coordinates. So starting with a 0. 0 is also the same thing as 2 pi, right? If you have your unit circle, the coordinates of 0 or 2 pi has a coordinate of 1, 0, right? This is like your x and this is your y. And then let's do pi over halves. Pi over half in your unit circle is about 90 degrees. And then that has a coordinate of 0, 1, right? This is your x, this is your y. And then pi is right here, all the way to quadrant 2. This has a coordinate of negative 1, 0, right? This is your x, this is your y. And then the last one, 3 pi halves, is right here. It's also in degrees, it'd be like 270, or exactly 270, not. And then that has a coordinate of 0, negative 1. So what were they asking? They were asking sine. So what is sine? Remember, sine is also the y value. So we'll start with, which one do you want to start with? You wanted to start with 0, okay? Sine of 0 So you got to find out what your y value of 0, and this says it's 0. Now let's do sine of pi halves. So what is the y value or the y coordinate of pi half? So here's pi half. This has a y value of positive 1. And then let's do sine of pi. Here's pi. The y value of this coordinate would be 0. And then sine of 3 pi over 2. Here's 3 pi over 2. The y value of this coordinate is negative 1. Okay, I hope that makes better sense. And if they want you to find the cosine, you just look at the x value of each coordinate, of each coordinate. Okay, so number 4 says, now we're dealing reference angles. Find the reference angle. So how I would do, so they give us theta, and then we got to find the reference angle. If you're curious, you can, reference angle can be abbreviated as the theta, and then there's like this prime number. So let's do A. So first off, is what I always do is draw where it is on the unit circle. 300 degrees is, what quadrant are we in? It's in quadrant 4. It's also 5 pi over 3, right? So here's 300 degrees, or 5 pi over 3 if you want it in radians. So here's theta. So it goes from 0 to here, that's exactly 300. Now the reference angle is usually the smallest angle. So what do you think this angle it is? Keep in mind that, remember, our unit circle is exactly 360. So this angle, we'll call this reference angle. Remember, we can abbreviate as reference angle as theta, and then this prime is going to be 60 degrees, right? Because in a unit circle, it's exactly 360. So, yep, the reference angle would be exactly 60 degrees. Now let's do B. So 2.3. Now this is a very small angle. So let's see here. What is 2.3? So theta is 2.3. 2.3 is between, it's between pi over 2, because pi over 2, if you put, literally, if you put pi over 2 in the calculator, you would get a measurement of 1.57. And it's between, so it's between pi over 2 and pi. Because pi is, if you put that in the calculator, it's about 3.146. So it's between these, between pi over 2. So remember, if you recall, pi over 2 is right here. And pi is right here. So this right here. So remember, 2.3 should be right smack in the middle. So here's pi over 2, and here's pi. So it should be right here. So this is my theta, right? This is what we want to find. We call that, that's our reference angle. So it's theta. You can abbreviate as theta and then the prime. So how would you do this one? So what you can do is do, to find that angle, you could do theta, or theta prime that represents reference angle. You could, if this whole thing is 180, so it would be 1 pi minus 2.3. So that's about 0.8416. Okay. Let's do the third one. Now we are going the opposite side. I think we're going forget what it's called. It's counterclockwise or clockwise. Well, anyways, we're going the opposite side. So negative 135. So negative 135. So remember, we're going the negative direction. So instead of going this way, we're going to go the other way. So negative 135 would be, so from here to here is 180, right? So from here to here, this would be negative 180. So 135 should be in quadrant 3, right? So it'd be right here. Here's exactly negative 135. And then our reference angle is this angle right here. So this would be positive 45. If you want, you can think of it, remember positive 135, wait, whoops. Oh no, how do I go back? Hold on, let me go back to my, there. So to, if you want, you can go positive 135. So positive 135 would be right about here, right? So the reference angle would be, it would be right here, 45, because this would be 45. So the reference angle with this would be positive 45. So reference angle represents as theta prime equals 45. So just remember reference angle is a smaller angle. And why didn't I use negative 45? It's because this would be positive 45, right? We're going this way now. Because if I go negative 45, it would be right here. And that's not what our reference angle is. It should be right here. Okay, so that was that one. Let's do example 5. So example 5 says evaluate each trigonometric function. So this one, you can draw it, or you could just literally get your unit circle out and then just find the cosine. Remember, cosine is the x value of the coordinate, and then tan is the y over x value of the coordinate, and then cosecant is, you can think of it as the reciprocal of the y value, or 1 over sine theta. So let me show you. So start with cosine. This is we got to find the cosine of 4 pi over 3. So where is 4 pi over 3 in your unit circle? 4 pi over 3 is exactly in quadrant 3. So 4 pi over 3 is the same thing as 240. So it would be right here. So here's 4 pi over 3. It's also, yeah, 240. And then this has a coordinate of what? In your unit, it says it has an x cosine value of negative 1/2, and then a sine value of negative radical 3 over 2, right? So we got to find the cosine of 4 pi over 3. So remember, cosine is technically just the x value. There's the y value. So the cosine of that would be, so cosine of 4 pi over 3 is exactly negative 1/2. Okay. Now let's find b, tan of negative 210. So first off, I always draw it, or you could just whip out your unit circle. Negative 210, we're going the other way, so 210. So from here to here, this is negative 180, so 210 would be right about here. So that's about 210 is, well, positive 200. if you do get lost, you could do the first you could do 210, positive 210, so that would be right here. Right? So that would be 210 would be 5 pi over 210 degrees. It's also the same thing as 5 pi over 4. So negative 210 would be right here in quadrant 2. And because it's part of the pi over 4 family, and in your unit circle, this would be 3 pi over 4, right? And how I remember this is because I automatically knew that it has a 4 in the denominator. And if you look in your unit circle in quadrant 2, where is it? Where in radians, where it has a denominator 4, 3 pi over 4, right? So 3 pi over 4 is technically the same thing as negative 210, right? And then that has a coordinate of, so 3 pi over 4 is the same thing as negative 210, and that has a coordinate of negative radical 2. Wait, no, it's the same thing as 7 pi over 6. My bad. So this is this is not actually this is 210 is about positive 210 is 7 pi over 6. And then so it comes from the pi over 6 family. So in quadrant 2, if you go negative 210, you're in quadrant 2. So where in the radians, where is it where it has a denominator of 6? 5 pi over 6, right? So 5 pi over 6 has a coordinate of negative radical 3 over 2, comma, negative 1/2, right? So we got to find the tangent. So remember, this is your x and this is your y. So tan of negative 210 degrees is going to be y over x. So that's negative 1 over 2 divided by negative radical 3 over 2. So this 2's cancel. So 2 negatives becomes a positive. So that's 1 over radical 3. And remember, you can't have, whoops, my bad. This should be cosine is positive in cosine is positive in quadrant 2. So this should be positive. So this should be a negative. So you can't have a negative in the radical. So you're going to rationalize the denominator by multiplying top and bottom by radical 3. So this is going to be negative radical 3. And then this is going to be positive 3. So that is your answer for tan of negative 210. And then cosecant of 11 pi over 4. So what is, you don't see 11 pi over 4 in your unit circle. There is 11 pi over 6, but no 11 pi over 4. So we got kind of, let's convert this radians to a degree. So remember how to convert it is just replace pi with 180. So this is like 11 times 180 over 4. So 11 times 180 is 1980. Divide that by 4. That's 495. And I know what you're thinking. I don't see 495 in my unit circle. It's not, yeah, your unit circle only goes to 360. So what we're going to do is do 495 minus 360. And that's going to be 135 degrees. Now, is 135 degrees in your unit circle? Yes. It's in, I think it's in quadrant 2. So here's 135 degrees. It's also in radians, 135 degrees is 3 pi over 4 if you want to do it in radians. So the coordinate of 135 or 3 pi over 4 is negative square root of 2 over 2, and then has a y value of positive square root of 2 over 2. So this is your x, this is your y. And then what is cosecant? Cosecant is the same thing as 1 over sine of theta. So that's going to be 1 over, so what is sine of 135? It's the y value of this. So that's going to be 1 over square root of 2 over 2. So this is going to be compound fraction. So this is going to be 2. So this is going to be 2 times 1 is 2. And then 2 times this, 2 times radical 2 over 2, the 2 disappears, you're left with radical 2. And you can't have a radical 2 in the denominator, so you're going to multiply top and bottom by radical 2. So that's 2 radical 2 over 2. And what cancels? The 2's. So your final answer is just radical 2. Okay, so that's all. That's how you do these ones. You could draw an image or just try to figure it out on the unit circle. Okay, let's do next example. Okay, so example 6 says, how many more do we have? Oh, this is the last one. So example 6 says, let theta be angle in quadrant 2. So they give us a quadrant, that's good, such that sine theta equals 1 over 3. We got to find a few things. For part A says find cosine theta, and part B says find tan theta by using trigonometric identities. So the first thing I would do is always draw the triangle. The good thing is they tell us this in quadrant 2. So we're in quadrant 2. There's theta. So they're saying that this is what was given, sine of theta equals 1 over 3. So what is sine? Is y over radius. So this length here is your x, and keep in mind that we're in quadrant 2, so it's going to be negative. And then this length here is your y, and y is positive in quadrant 2. So, and then this thing here is your radius. So this 1 is your y value, so that you're going to put a 1 here. And then this 3 is your radius, so this is going to be 3 here. Now, all we got to do is in order to find part A, we got to find this missing side length, right? The leg, the x value. So we can use, what you could do is use the Pythagorean theorem. So it's 1 square plus x square equals c square, or a radius square. So that would be 3 square. So that's 1 plus x square equals 9. And then subtract 1, you get x squared equals 9 minus 1 is 8. Then take the square root of both sides. And then, can you simplify square root of 8? Yes, you can. This would be 4 and 2. So this is going to be 2 radical 2. Now, keep in mind, we are in quadrant 2, so this is going to be negative. So this is negative 2 radical 2. Okay, so now let's find part A. Let's find cosine theta. And if you recall, cosine theta is x over radius. So my x value is this whole thing. So it's negative 2 radical 2 over my radius, which is 3. And then my b is tan theta, which is y over radius. No, my bad. It's y over x, right? Not y over radius, it's y over x. So my y value is positive 1, and my x value is negative 2 radical 2. So you can't have a radical in the bottom, so you're going to multiply top and bottom by square root of 2. So 1 times radical 2 is radical 2. And then radical 2 times radical 2 is 2. And then you have to times it by negative 2. So your final answer is going to be radical 2 over negative 4. Okay, so that is your final answer. Okay, so I hope this section was helpful. I guess we'll just call it a day. Thank you. Bye-bye.